negatively, and we didn't ask them to. They just did. And other people interpret it positively, and we didn't ask them to do that either, and they just did. So what determines your negativity or your positivity bias, and is that even important? And does that predict outcomes for you in the future? Well, the way we run studies in our lab here is we just give you 2 buttons. If you think what I show you is negative, press the left one. If you think what I show you is positive, press the right one. We show you one face at a time. We start by showing you faces we think we know what you're going to say. Most people are going to say negative here. Most people are going to say positive here. And then we show you the surprise faces, and now you can tell us what you think about that. And we can graph it for you so that this is % negative ratings. If each dot's going to be a person, if you're up high, you're saying negative most of the time. And that's what people do to angry faces. And what they do to happy faces is they say that they're positive most of the time. And then those same individuals, when they're rating surprise faces, beautifully, just like human beings do, spread out and differ in their propensity. This person said these things were negative 80% of the time. This person said they were negative only 10% of the time. So we can start to create a group of people who we might want to call optimists and versus pessimists. Sorry, I'm up here. So pessimists and optimists, right? The other thing we can measure is how long it takes you to make this decision. It takes you less than a second to tell me that that's negative and less than a second to tell me that's positive. It takes you longer to make the decision about surprise. Makes sense. You got 2 things. You got to pick one. But the other reason it takes you longer is amygdala and prefrontal have to have a conversation in the case of surprise that they don't have in the case of anger or happy. When you have a clear decision to make, amygdala doesn't need that much help from prefrontal. But when I show you surprise faces, if you think they're negative, you show me high signal in the amygdala. That's consistent with all the backward masking stuff and the fear face stuff. But only if you say they're positive do you show me high signal in the prefrontal cortex, and then we think causally, although we can't prove that from these data, we think causally we see low signal in the amygdala. So what we think happens is amygdala is a pessimist. It's there to protect you. Anytime it sees wide eyes, it screams, it cries wolf and says we're in trouble. If the cortex agrees, then you don't have any signal in prefrontal, amygdala stays high, and you say the face is negative. If prefrontal has memories about birthday parties or whatnot, it's going to send back an override message, quiet down the amygdala, and you're going to spit out a positive rating. Okay, so that extra regulation is going to take a little more time. So I'm going to show you one recent finding in our lab, and then we'll finish up here. Since we know that these are connected by a cable, if you will, these axons are all grouped together in a pathway, we can measure the thickness of that cable with a brain imaging technique called DTI, or diffusion tensor imaging. And what we're interested in is your differing levels of normal anxiety. So we're all anxious. Some people are high anxious and jumpy, and other people are really calm. And you're going to differ on these scales, and we can measure that. And then what we can do is take those numbers and then measure how thick your cable is between your amygdala and your prefrontal cortex. What we find is if you have a nice thick pathway, you report lower levels of anxiety in your life. But if you have a thin pathway, you report higher levels of anxiety in your life. To the extent that amygdala and prefrontal can compare notes, and prefrontal can keep amygdala calm, you report being less anxious. So that's a structural finding in terms of the thickness of the axons between the 2 areas. I can show you one functional finding. Instead of talking about normal levels of anxiety, we can now jump to when anxiety becomes diagnosable, when it's a disorder. And the answer for you is as you sit there and diagnose yourself in your chair, is when is it a disorder? The answer is when it's functionally impairing your life. One disorder we study is generalized anxiety disorder. This is worry. We all worry. This is people who are losing 4 hours a day on a couch and unable to go to work for the 3rd day this week. That's when it's functionally impairing your life. That's when you need to get help. If you study a group of people like this and they're going to be treated, some of them are going to choose drugs. Some of them are going to choose selective serotonin reuptake inhibitors. It's a really good drug. If you're incredibly anxious and you can't get any of your work done, this drug can get you back on the playing field. And then you're going to have to go do some talk therapy to give yourself some tools because the drug's not going to work forever. But what we know is going to happen is it's going to work for about 2/3 of people who try it. And it's not going to work for 1/3 of people. And our problem is we don't know who is who. This is very trial and error. We just try it out and see, and that's not working, we switch it to a different substance. What we did is before people were about to be treated with their SSRI, we threw them in the scanner and showed them fear faces. So now we know what their amygdala and their prefrontal cortex is going to be doing. And we sent them away and let them be treated by their doctor. We didn't have anything to do with the treatment. They all received the same SSRI. They came back to us in 8 weeks. What we found is before they started their drug now, if they showed high prefrontal and low amygdala activity to the faces, that predicted they did very well on this drug. And if they showed high amygdala and low prefrontal, this SSRI didn't work for them. This is predicting some sort of integrity of communication between prefrontal and amygdala that the drug can work with. All right? And so this is an exciting finding because if one day, and we're not there yet, this is one substance, small group of subjects, one disorder. But the goal would be to try to use fMRI diagnostically. If you could predict, if you could put somebody in a scanner in 20 years from now and say, you're 20 milligrams of Paxil, would be a really nice thing because you could save someone a year and a half of angst as they go through different doses and go through different substances. So that would be a long-term goal. I'll repeat that we're nowhere near that yet. So we started by talking about Phineas and how he lost control of his ability to regulate his behaviors. And what we can think about is when the tamping iron went through, it got some gray matter, it got some neurons, but what it probably did is it cut that cable. It cut the connection between prefrontal and amygdala. So now he's a walking amygdala. Now he is going to emote in the moment, and he's not going to be able to regulate it. I showed you a very simple way to access this circuitry by showing people faces that where their valence is not clear. Valence just means how positive or negative is it. And you see that you get a regulatory circuit here, one that we think when it goes awry is what's your problem when you report having high anxiety or cross a line into an anxiety disorder or even depression. I told you that it takes longer for you to make the decision about whether it's positive or negative. What I didn't tell you is it takes the longest to give it a positive rating. It takes you a little bit longer to say that face is positive. I think that's because in that case and in that case only, prefrontal's got to come in and calm amygdala down first. And that process takes takes longer in the first case to say anything, takes even longer to be an optimist. It takes a little bit more effort to be an optimist. These old areas of your brain were built to protect you. They were kind of built to see negativity in everything. And that's a good adaptive thing in terms of survival. So you've got to do a little more work to turn some of that around. You don't need to be a pessimist if you, and I think it's helpful to realize that this battle is ongoing and to kind of visualize this in your own head as you think about controlling your own emotions. So with that, I think I will say I'm done. Thank you very much.
And we have 160 liters of liquid in the other room, so if we run out, we can Go ahead and throw it all.
All right, Hannah. You want to come get pour? It's pretty hard, yeah.
Yeah.
You guys did it.
Hardened up nicely. Hello.
Hannah, have you ever made ice cream before?
You got your own spoons, right?
Yes.
So what do you think?
Yeah, I've made regular.
Want me to serve it, or you want to just?
Do you want to have people serve themselves?
Yeah, I think you should.
Like our 5
Because that's not coming off that plastic spoon. I'll tell you
I
that.
have a great date, Hannah. I have a great date.